Today, we're going to talk about something that sounds a bit wild. How one single scientific project, the Muon Collider, could set off a chain reaction of new technologies that totally reshape our future, not just here on Earth, but out in space, too. I know, it sounds like something straight out of sci-fi, right? How on earth can a machine that's built to smash tiny little particles together have anything to do with building colonies on Mars or creating a global clean energy grid? Well, that is the exact question we're going to unpack. Let's get into it. All right, so to really get this whole ripple effect, we've got to start with the single drop of water that kicks it all off, the Muon Collider itself. This thing isn't just another machine. It's a huge leap forward in our big quest to understand the basic rules of the universe. So, first things first, what is a muon? The easiest way to think about it is like an electron's bigger, heavier cousin. And I mean way heavier. We're talking over 200 times more massive. And that extra weight, well, that turns out to be the secret ingredient that makes it so incredibly useful for physics. And that extra weight is where the magic happens. The advantages are huge. Because muons are so heavy, you can get them up to incredible energies in a machine that's way, way smaller. But the real game changer, it's the data. See, protons are kind of messy. They're not fundamental particles. They're like little bags of other stuff. So when you smash them together, it's a chaotic explosion. Muons, though, they're fundamental, clean. When they collide, you get this beautiful, precise picture of the physics at play. Okay, but here's the thing. Building a collider like this is not easy. In fact, it's ridiculously hard. You literally have to invent a whole new toolkit of materials with properties that honestly sound like they belong in a superhero movie. First up, we have something called metal organic frameworks, or MOFs for short. Just picture a tiny, tiny molecular sponge. It's this incredibly engineered, porous material that can just soak up and hold a ton of supercooled hydrogen. And that is the key to solving one of the collider's absolute biggest hurdles, how to cool down the super unstable muon beam.
And the process for doing that is called ionizing cooling. It's actually pretty brilliant. You build this lattice out of MOFs, you flood it with that super cold hydrogen, and then you just shoot the muon beam right through it. As the muons zip through that dense hydrogen, they lose energy, they calm down, and the beam gets tighter and more focused. It's just an incredibly elegant solution to a massive engineering problem.
All right, tool number 2 in our revolutionary toolkit, carbon nanotubes. I want you to imagine the strongest but also the tiniest pipes you can possibly think of. We're talking pipes that are literally just atoms wide, but strong enough to guide a beam of particles. That's what these are. They're the perfect microscopic plumbing for a muon beam. And get this tech is so powerful, so precise, that you can contain and steer the entire muon beam in a space of just a few dozen centimeters. Think about that for a second. That is an absolutely mind-blowing feat of materials science. It could change how we build accelerators forever. Okay, so we have our toolkit, right? We've invented these incredible new materials. And this is where the story explodes beyond the lab. Because these things, designed for a physics experiment, could actually become the literal building blocks for our future in space. So remember those molecular sponges, the MOFs? The ones we're filling with hydrogen to cool down a particle beam? Seems like a pretty specific kind of niche job, right? Well, it just so happens that hydrogen is also one of the best materials out there for shielding against cosmic radiation. So that exact same MOF technology could be used to create shields to protect our future astronauts and habitats on the moon and on Mars. And we're not just talking about one little thing here. This unlocks a whole universe of possibilities. Think about it. You could build orbital data centers, totally shielded from those damaging cosmic rays. Why? Well, you'd need them to control asteroid mining robots from an orbit around Mars in almost real time. And, of course, it provides the absolute must-have radiation shielding for any long-term human settlement out there. But hang on, this story doesn't end in space. Not even close. This same toolkit, the one we came up with for the Muon Collider, has the potential to completely remake our own planet, helping us tackle some of the biggest problems we face right here at home. You see, those same MOFs that are so good at cooling, well, making that kind of cooling cheaper and way more efficient could totally change our power grid. We're talking about enabling ultra-high voltage DC power lines. These are basically superhighways for electricity, with almost zero power loss. We could run them under the ocean, creating a truly global energy grid that can shoot renewable power from sunny deserts or windy coastlines to anywhere on Earth that needs it. And once you have that global grid, it opens the door to an even bigger idea,
maritime spaceports. Imagine these huge offshore hubs that are basically centers for a circular economy. They'd use clean, renewable power to literally suck CO2 out of the air. Then they turn that CO2 into carbon-neutral fuels for things like cargo ships and even rockets. And any extra CO2, you just safely store it deep underground. It's a system that takes our biggest waste product and turns it into a valuable fuel. And just take a step back and think about what that means for the world. When every country is plugged into the same shared energy system, it creates this deep economic interdependence. It builds a foundation for everyone to prosper together. And, maybe, just maybe, it leads to a more peaceful world. The benefits here go way beyond just the tech. And that brings us to the final piece of this puzzle. And honestly, it might be the most important part. Because this whole journey, it's not just about building amazing machines or a cleaner planet. It's about what this kind of deep scientific quest means for us, for humanity. There's this really powerful idea at the heart of all this. The closer we get to understanding how the universe actually works on a fundamental level, the better we can build a society that's in harmony with it, a society that's truly sustainable. So why does all this matter? Because pushing the boundaries like this forces us to grow. It makes us discover things we didn't even know we were looking for. It helps us figure out our place in this vast cosmos. It inspires us to think big, to build these incredible multi-generational projects like a global grid that will outlast all of us. It connects that deep search for scientific truth with our own personal search for meaning. So in the end, all these technologies that could spin out of the search for a Muon Collider, they really give us a choice. They hand us the tools to build an incredible future, a future that isn't just sustainable and prosperous, but one that's genuinely inspiring. So the real question, the one we all have to answer, is what kind of future are we going to choose to build?